Hello. Today we're going to talk about scientific notation. A notation is a way of writing a word bleh. Hello. Today we're going to talk about scientific notation and how to write a number in that notation. Up until now, you have learned 3 different types of notation. One of them is standard notation, and that is how we write any normal numbers. So if I asked you to write 125, you would write 1, 2, 5. Expanded notation, if you remember from elementary school, that's when you write it by place value. So you would have 100 plus 20 plus 5. Word notation is exactly what it says. You would write 100, 25. And today we're going to talk about scientific notation, in which mostly we use this in science class to write really big numbers or really small numbers, in which the number 125 would look something like 1.25 times 10 to the second. So that's what we're going to be working on today, is how to write a number in scientific notation versus the other notations. So we're just building upon what we already know. So if we look, we have a number here. It says the common cold virus is 0.00000003 centimeters in diameter. Bacteria is approximately 5 times as large as a virus. How large is the bacteria? Well, if it was 5 times that would be pretty simple to figure out. You would just take the diameter of the cold virus and we would times it by 5. Now you'll see as we go to times this, 3 times 5 is 15, carry the 1, that gives you 15, and then you have 5 times 0 is 0, 0, 0, 0, 0, 0, 0. So as you can see, the problem becomes all these zeros and the mistakes that we could make by having to calculate all these zeros and keep track of them. So scientific notation is a method used to help us perform operations with really large numbers that have lots of zeros after them, or really small numbers that have lots of zeros before them. So let's look at this. It says when you are dealing with very large or very small numbers in science, it's helpful to be able to write them in shorter form. Scientists and mathematicians use a form called scientific notation. And this is what you have to remember. Scientific notation is a number between 1 and 10. So that's how you write it, any number between 1 and 10. And then times 10 to some exponent. So when you see a number written like that, you know it's in scientific notation. So again, I have the form at the top of the screen here, and we're going to write the mass of the Earth in scientific notation. So imagine that you're a scientist and you're calculating different calculations with the mass of the Earth. All those zeros, having to write them and rewrite them and multiply them and divide them, it would become very confusing and very easy to make a mistake. So we write the number in scientific notation. So the number has to be between 1 and 10. So what we're going to do to make that number smaller is we're going to take the decimal point that's at the end of the number, just like a period's at the end of the sentence, and we're going to move it all the way after the first non-zero digit. So now my number is going to be 5.972. And I don't have to write all those zeros. Now you're sitting there going, but 5.972 is not even close to this really big number. So that's where the times 10 to the exponent comes in. So every time, if you remember, when you take a number and you multiply it by 10, what happens? Well, we move the decimal point over one spot. So instead of 3, it's now 30. My decimal point moved from 3 to after the 0. If I take 1.5 and I times it by 100, my decimal point is going to move to the right 2 times. That's 150. So if you remember that same concept, we're going to multiply this number that we created with the decimal point times 10, and we're going to multiply it as many times as we need to get the decimal point back where it belongs. So we're going to multiply it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we would have to multiply it 10 by 10 24 times. So that's the 10 to the 24th. So that exponent there becomes the number of times you move the decimal point. So I chose this number for a very specific reason. The most common mistake that students make is they think that the exponent is the number of zeros. It's not. It's the number of times you move the decimal point. So that's why I chose this number, because I wanted you to realize it wasn't just 1, 2, 3, 4, 5, 6, 7. 7 times 3 is 21. It wasn't just the 21 zeros that are after the number. It's also these other 3 place values. Okay? All right, so let's look ahead here. It says a supercomputer can perform a really high number of operations per second. So write the quantity in scientific notation. So go ahead and pause the video, try to write these in scientific notation, and then hit play and see how you do. Okay, so at this point you should have tried, at least attempted this, and you're checking your work. So if I look at my number, I know that my decimal point is nowhere to be found, so therefore it must be at the end of my number. So I'm going to move it to after the first non-zero digit. So that gives me 1.353. Now you don't have to write all the placeholding zeros, but you do have to write the non-zero digits. So don't just write 1.3 or think you can round it to 1.4. You have to write all the non-zero digits that come after it. So the next part is going to be times 10. And then remember, it's not the number of zeros, but the number of spaces you moved it. So we look here and we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14 spaces. You can always check your work by taking 1.353 and timesing it by 10 to the 14th, and you should come out with that number. Or move the decimal point 14 places and you should end up with this number and 9, 10, 11 zeros after it. All right, let's look at the next one. We have, this is a little bit more manageable, right? So the decimal point's at the end. We move it after the 3. So we get 3.476 times 10 to the 1, 2, 3, 4, 5, 6th power. So when writing really large numbers in scientific notation, how do you determine the value of the exponent? Well, you should have remembered that the value of the exponent is the number of zeros. That's the big idea here. The number of, sorry, I messed that up. The number of spaces, I told you what you weren't supposed to do. The number of spaces you move the decimal point. So if it's times 10 to the 5th, I moved it 5 numbers, or not 5 spaces. It's not zeros. It's numbers or spaces. So keep that in mind. That's the number one mistake students make. Okay, and then we have Avogadro. So Avogadro created this number, and it's called a mole. And the mole is the number of particles in a given substance, and it's equal to this big, huge number. Well, we don't want to have to work with all of those zeros, so we're going to write this in scientific notation. But if you notice, the zeros are on the left instead of the right, which makes this a very, very, very small number. So we're going to still follow the laws of scientific notation, and that is that the decimal point goes after the first non-zero digit. Well, in this case, I'm heading to the right, looking for my first non-zero digit, and it's there. So that's going to be my number in scientific notation. So it's going to be 1.66054. Again, you have to write all the numbers that are non-zero until you get to the zeros. So all of those numbers have to go. We're going to do times 10. Now, and this is where it is a little different. If I take 1.66054 and I times it by, like, say, 10 to the 5th, my number is going to get bigger. I'm going to end up moving my decimal point to the right, and I don't want that. I want my number to be small. So that means instead of multiplying by 10 to the 5th, I'm going to be dividing by 10. So to show division, if you remember when we talked about negative exponents, a negative exponent is shows division. So for example, if I have 10, whoops, I lost my marker. So I'm going to come here. If I have 10 to the negative first, that's the same thing as 1/10, or dividing by 10. If I have 10 to the negative 2, you remember that's the same thing as 1/100. So you're dividing when you have a negative exponent. So what I'm actually doing is I'm taking this and I'm dividing it to move it to the left. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So that's going to be the negative 27th power, because I want this number to be small, very, very, very small. So I'm going to be dividing it. Well, you're not going to get anything as ugly as that number. So let's try something more manageable. So let's look at this example. We have 0.000059 in scientific notation. So the same rules apply. Take your decimal, now you're going to take the decimal point where it is, and you're going to move it after the first non-zero digit. So it's going to be 5.9 times 10, always times 10. Then remember, the exponent is the number of spaces you moved it. So it was here, and I moved it 1, 2, 3, 4, 5, 6. But I moved it in the opposite direction, so it's going to be a negative. And again, if you wanted to check your work, which you should, if you had 5.9 times 10 to the positive 6, that means you're multiplying it by 10, and every time you multiply it by 10, it's going to get bigger. And you can see already that that number would be really, really big if I multiplied it by 6. That's not the number I want, so I know that's not true. I know I have to move it the opposite way. Now, let's do the inverse of that. What happens when I have a number in scientific notation and I want to write it in standard form? Well, this is actually the easier of the two, because all you have to do is find that exponent. That's the number of times you move the decimal point. So I'm moving it 3 times. And the sign tells me in which direction. So if it's negative, I want it to get smaller, which means I'm going to move it to the left. So I'm going to move it 1, 2, 3, fill in your zeros. So you get 0.00486. Okay, what happens on a calculator? Well, a calculator is nothing more than, it's not going to write the number really big for you. So you're going to write it, it's going to give you EE, or sometimes it's going to give you times like 10, like an exponent. So what this is all you have to do here is replace the EE with your 10, and then that becomes your exponent. And then everything else stays the same. So that's kind of easy, but I wanted to go over it because it is on the PSSA. So how would the calculator write this? Same thing, you start with your decimal point. It goes after the first non-zero digit. So it's 4.65 times 10, and then your exponent would be 5, so it's going to be 4.65 negative 5 because it's less than 1. It's a small number.